Good afternoon. I'm Navin Singh, and my background is I'm senior technology architect and data scientist. And I've been working with businesses. They want to move into artificial intelligence, but the methodology they are adopting is which is not a good fit to be in the position where they can work on and build a product which they can implement in their production environment. So this presentation is the roadmap if a company want to be AI ready, what they need to take it. This presentation overview slide, we develop a AI strategy, and this is going to be the talk of the presentation. Every business has business problems, business processes, and business goals. And when they wanted to implement AI strategies, they have and measure their culture and environments if they are AI aware, their AI culture, and their AI maturity. There is the another wall in terms of brick. The data is an important part when we are implementing any AI strategy. Data is gold. We have to identify data collection, data transformation, and AI environments. The further side, we will be discussing throughout the presentation AI development, product development, AI team which involves in the development, AI frameworks, and application integration. So these are basics which I divided my presentation. It's a lot to go, but I will try to sum up as we go ahead. So before we start with AI overview, and in terms of understand artificial intelligence, we have to come up with artificial intelligence and human intelligence and compare them where they stand. Human intelligence is dependent on intuition, common sense, judgment, and creativity, beliefs, etc. On the other hand, artificial intelligence has the ability to simulate human behavior and cognitive processes. Human has ability to demonstrate their intelligence by communicating effectively, where machines learn from humans, capture and preserve their expertise. Humans have plausible reasoning and critical thinking, and on the other hand, fast response, the ability to comprehend large amount of data and process them quickly is one of the plus point for the artificial intelligence. So now, given that, what do you think where we stand in terms of AI to achieve the human intelligence? If we think of AI timeline on a vertical axis and AI performance, where how is AI is approaching in terms of the time, you will find this kind of curve. And I don't want to put a year in particular, but if you will see, there was a lot of innovation and a lot of studies was done, but it went down because of limited processing power and computing capabilities. But the moment we got ahead, the AI start picking up. So in 2012, the invention of neural nets. After that, AI has started picking up, progressed pretty quickly, and in today's time, artificial, what we say it is at artificial narrow intelligence, which is considered as less than human intelligence. So if we put, this is 2020, if we put, and we are predicting the way AI is progressing by 2040, or maybe you might argue over the timeline, but 2040 or 2050, whatever the timeline is, AI is predicted to have the artificial general intelligence, which is equal to human intelligence. 2060 and onwards, what will happen if it surpasses the human intelligence? These are a lot of questions to answer, but that is something to think about what is required once AI surpasses the human intelligence. So basically now we wanted to go a little bit deeper in the AI to understand what artificial intelligence is, what it constitutes. So the definition is given by Eric Horvitz in 1990. This is AI is the computer-based exploration of methods for solving challenging tasks that have traditionally depended on people for solution. And such tasks include complex logic, inferences, diagnosis, visual recognition, comprehension of natural language, game playing, exploration of explanation, and planning. Now, if in simple terms, if I want to visualize this definition, we have human which has a ability to talk and understand each other. This become the area of speech recognition. We can see the objects and store in our memory, identify it. That becomes a part of computer vision. Robotics, human has the ability to identify the objects, identify the hurdles, and determine the next course of action. They have ability to read and write and communicate. That become the part of natural language processing. And with their ability to be logical predictions and recommendations, that is become the part of artificial intelligence. So in terms of, I will go few of the slide quickly because we have a less limited number of time. So there are the certain application I will be discussing in the each area. Then we will jump over to vision. You can see determining the faces, identify characters, handwritten characters, or recognizing the signature. This is one of the area where computer vision or many applications works on these technologies. Natural language processing, you have already seen the language translation and chatbots, and many talks has been going on these in this DevFest. Reinforcement learning is one of the area where machine is trained based on punishment or reward model. Self-driving car is one of the example, and how machine determine what action to take based on the environment they have. And another is the robotic mechanical hand, which can identify how to pick and what and how they can shape their hands to pick different types of objects. So these are they are continuously picking the objects and training and adapting themselves to identify and make those kind of gestures. Prediction and recommendations. Recommendations is the one of the part which you have seen in many algorithms. But for example, if similar user or it's a similar content which user want to access. And on the other hand, if we talk about predictions, stock prices, what will be the value of a stock in future is one of the area where predictions comes into the picture. But there are many other application area. These are just a few examples. If you are talking on understanding machine learning, there's the classification problems where you have input features, for example, patient data, and identify if there is a disease present in the patients or not. Other thing is banking fraud detections, which is, I think, Capital One has many application showcase in that area. And that is an old cases to identify spam or not a spam. So if I summarize how and a different area of artificial intelligence in terms of the learnings, and as part of computer science, artificial intelligence can be divided into the two parts: symbolic learning and machine learning. Symbolic learning is based on symbolic processing of data that include robotics and computer vision. And in terms of machine learning, we have a lot of features, lot of data, and ability to process them statistically. This becomes the statistical learning based on the data we have. if we made our model based on neuron or the capability to like mimicking human brain, which is based on axioms and neurons, that is the deep learning. Deep learning is further can be divided into next level convolutional neural networks and recurrent neural networks. In the area of statistical learning, we have supervised and unsupervised learning. Supervised learnings are where we have given input and outputs. We know for a given input what we have output. Based on that, we trained our algorithms, and we use them for the classification or identify categorical variables or regression to predict something which are in the future based on that variable. Unsupervised learning is just based on we have input data and we can classify them, segment them, and that will solve a lot of segmentation and clustering related problems. So this is as a part of a computer science, we have to understand where and how we have to implement. There are the few machine learning algorithms which is part of classification, which has been widely used by many organizations in many different streams. I am not going to talk about all of them because each of them has a specific use case and application of that, and there are multiple examples how you can build the models based on each of these algorithms. So if you see the classification, then we have a regression, linear logistic, and clustering algorithms. So let's talk about product management, how the product management in artificial intelligence is different than the traditional management. The traditional application development based on the software development life cycle means like it's a waterfall model. You have the requirement, you design it, and you predict it. You start developing it. On the other hand, when we have a AI model or AI product to build, for example, a speech recognition system, the important thing is you need a sets of data and use cases rather than wireframe. If you have to build this speech recognition system, you have to work with a number of speech clips which is taken into different environment like driving a car, low bandwidth, public area, and with different accent. And if you wanted to build a chatbot, you have to come up with a series of conversation which can happen between the customer or the bot agent, and at least you start with 100 conversation in particular use case, and these use case and what you want to achieve, then the data science engineering has worked hand to hand to build this realistic AI product. So this is one of the use case which can come up. So here the both engineering and data scientist and the product manager has to work in hand to build this. And why it is important, we will be going through the next development model, how it works, how we can solve these problems which we have discussed. So if you see, you start with a problem statement. With the problem statement, you will generate hypothesis, what you're trying to achieve. For that purpose, you gather data. Once you gather data, one of the important part is cleaning of that data. Data cleaning is an important part once you are working on artificial intelligence models. Data cleaning involves multiple steps. That also involves the data analysis. You have to understand business analysis to go through this data, explore the features, identify, analyze the data, and validate the data. In the data cleaning, once you are working on artificial intelligence, one more factor which is important is you have to remove the biases. Statistical biases identify what data is fit for your journal application. So you have to remove the statistical biases and that go in a loop until as you get the data which you are looking for to build your to solve that problem. In the black box, we have artificial intelligence algorithms. Some of them we discussed in the previous slide. And based on these algorithms, we implement those models. We implement those models to capture what the predictions these models have been making to provide us the results. And these results we can capture and test them. We verify them, and again we can record into our system to identify what prediction we have made, what we have identified, whether it achieved our purpose or not. So this is the basic AI development model when you start to address a problem in business. That is the life cycle you have to go through. So this is focused to a development model. But if you get into the details of the models, how your model is developed, you have to gather the data, you provide the input functions, then you have to pick the model functions, what kind of algorithm you wanted to choose. You have to make a train and test split. You train your data, evaluate it, you predict and save your model. So this is the basic. Any algorithm you will pick in artificial intelligence, either it's a machine learning or deep learning algorithms, whatever the framework, whatever the technology you have been using, you have going through these cycles. You can evaluate, you can tune these models based on parameters, and once it is ready, you can execute this model. Once we have these things, one of the important factor once we discuss this data transformation for AI, once we are doing this data and building the AI models and doing a AI based product development, we have to make sure we have right data. Once we have right data, we have a consolidated data which is required for our use cases. We have to identify the data has a proper quality which is required, and we label that data, we tagged that data for the development purpose. In addition to the tagging, the data should be owned and the owner should be identified. It should be shared and protected. The other part is the governance should be provided, how the data will be governed, and it should be disaster proof. Because we are doing so much of investment to building these AI models, and data become an essential part of our exploration process, then we have to identify all the players and who is the provider of the data. It is coming from our in-house or we are getting it from outside. So these are a few of the data related measurement that we have to identify before we build a AI model. These models doesn't work in standalone. It's good for working when you are in a small environment or you are building this model and try to show it can predict. You can estimate the prediction, your results, like it might be efficient enough. It is their predictions are 80% correct or 90% correct. But if you will see, like these models, you have to implement with your existing applications. And integrating model is an important part. Once we have data, we have to identify all the application, how do we integrate these models which we have developed, how continuously data will be provided, and how they predict the result and transfer that findings into the another applications. These are the one of the things which you need to integrate. Now, given all that information, if a company want to build a AI strategy, what they need to have all in their mind. So once artificial intelligence, first important thing is the AI platform, what AI tools to consider, what team they have to identify, processes, which processes they have to modify, and we will discuss about every business has the capability, existing capability, whether they need to develop it, and the organization structure what they have, and the partners which they communicate the data. The thing is, AI platform, we have two decisions to make, either it's a cloud provider or on premises. If on the other hand, if we determine what we have a tools, then we can think of if we have to go to a cloud provider, use their AI capability, or we use open source system to tools to utilize. If we have a team, do we want to train AI in-house team, or we want a consulting firm to come up, or they can build a hybrid model, they can come up, train some of the team members and build a team which can work on that. In terms of processes, every business has existing processes, and in these processes, what process to enhance, that need to be identified, and this is a very complicated area because everybody, when they write on AI buzzword, the important question is how to choose. The capabilities which provide, if we wanted to enhance the core capabilities, or we wanted to build, work on known core capabilities. So the differentiator here is the terms of risk. If we wanted to work on a core capabilities, if we get into the AI model there, because the investment is huge, the chances of success might be sleek in terms of if we are, so the company might take a huge risk. So rather than building, they wanted to enhance some of the capability, or they can work first on the known core capabilities and reduce the risk. Partners is important when we are working, because not all the data you have in the world. You have to work with the partners, you have to build new partners, or you have to train the existing partners and make them AI ready, and ask them what you need. So when a company is building a AI strategy, they want it to be generating an AI model, they have to come up with holistic approach which they have to go through. If you are in terms of a job market, what roles are when you are building an AI team? The business analyst is important, who understand the business. Data analyst is who understand what data is required. Here then the data architect, they understand the structure of data, and there are the other data related jobs, which is the data engineers, which design, data designer, and administrators. So the lot of people who are in the data, they require data engineers, which will provide the data which is required to these data scientists, which take this data and work on the models and try to extract the features, predict the result, and compare these models. Two roles which are important, because a lot of people, when they are working in the organizations, there is a communication gap between the leadership and the members, because the data people cannot explain what their role is and what they are trying to achieve. On the other hand, data scientists, they are busy working with these models. They don't know how to communicate with the leadership. Or then the two people which is really important is the enterprise AI architect and the business architect, whose role is to talk to decision makers and try to update and understand what is the business requirement and how they can fulfill it, or how they can influence the decisions which they are going to make. Machine learning engineers, so these are the people who learn through machine modeling and try to build try to build different algorithms and try to improve them, but mostly they are outside of your organizations, and many big companies are working on that. So in terms of AI field, when we terms as mostly the purpose of showing all these roles is when it comes to AI, most of the company just build a model, show them this can predict 80%, and try to show that they are ready for AI, which is just a starting point. But when a business need to full-fledgedly get into the artificial intelligence, they have to go through multiple steps. I have gone through a lot of things. I think this presentation was quite longer, which I reduced to fit the 45 minutes. There are certain things which is, if we get into more technical part, once we have to develop the development environment, basic framework or basic language most people use is the Python. There are R or other languages they can use, and there are the fundamental libraries which they need to use on top of Python. One is the matplotlib, which is graphic library to represent your data. Panda is a data libraries which you can manipulate data, collect data, and do a lot with the data. NumPy and SciPy are the two additional libraries for scientific data processing. Scikit-learn is one of the important library which you have to use, which provides multiple machine learning models, and very widely used library. Additionally, the invent of the TensorFlow, which provide a way to process more of a deep learning and neural networks related problem. TensorFlow has been really a great success to ability to provide the lower level libraries. And on top of TensorFlow or these libraries, there are the top level libraries which can be developed, which is the Theano, Caffe, and Keras. So the TensorFlow or these library, these are the wrapper which provide a simple interface which can be wrapped and provide a more of the functionality which can directly achieve through TensorFlow, or they can work with each other and the multiple environment. The sum of the features you can develop your own, but if you are in a talking to Google providers like Microsoft, Amazon, and Azure, GCP, and AWS, they provide the speech recognition, NLP, and vision algorithms, and a lot of APIs which can be integrated to solve your purpose. Or you can experiment if you are working on a specific use case on NLP in your business environment, you can write a custom code. So this is where you develop a custom environment, or you can use the cloud-based provider to use their machine learning capabilities. Either it's Microsoft, Google API, Google AI, or Microsoft AI. You can use these cloud providers to use their way to store and provide a AI algorithms. Once you feed them the data and define the parameters, they can predict the result. But it depends on how simple your use cases are, how complex business problem you are trying to solve. What if you wanted to build a simple business case to display to your businesses what they can achieve through this implementation. The cloud provider can be a quick way to go, but if you wanted to build a comprehensive environment, that is the custom environment you can build. So once you have these things, that you can move your organization from fall to spring, and make your organization ready for artificial intelligence implementation. With this, I have few minutes left, so if you have any particular questions, I can address that. Yes, ma'am.
Thank you for the talk. Earlier you mentioned needing to have data governance, and I was curious for the cloud-provided AI solutions, how do you do the data governance when the AI and the model is given to you versus custom developed for you?
So the data which you are talking about, the cloud provider, uh, again, that cloud provider just providing the infrastructure, and that is your company's responsibility how you store that data in your cloud. And once you are storing that data in the cloud, either it can be S3 in case of AWS, or it can be their NoSQL databases. That is where the architecture and governance, you have to provide what data you can put, what rules to take. That kind of a governance, that is to determine by the company policies. If it's insurance or banking organizations, they are high, or health organization, they are high. But if you are a simple business customer oriented organization, you may not need to have that level of governance of the data. So it depends on, again, how you are doing that, but it's not the responsibility of cloud provider. It's the responsibility of the organization to provide that governance. Yes.
So thank you for the presentation. In your experience, where do companies go wrong in this kind of strategy, or where do they underestimate how much work it's going to take to reach the goals that they have?
So one of the basic problem that happens, the mismatch of quickly building a model, picking up artificial intelligence. What product managers try to do, they build a model and try to depict my model can perform 80% and it is good enough. But in the meantime, they don't understand the whole data behind the organizations, and when they plug in these two things, most of the time things don't go in a right direction. It requires a lot more effort to understand that the decision should be data driven rather than not an application driven. You can pick any algorithm, implement, pick some 10,000, 20,000 or 100,000 rows and build a model. But once you wanted to build how to access the data, how to put into a runtime environment to really get a real-time feed to the data, that is where they underestimate. And the first thing is the effort and the amount of effort it takes to integrate both of the things. And the thing is, a lot of data related problems then come. I can give a few examples which is simple. For example, for FINRA, if you know that, they collect the data from different organizations, which is stockbrokers, and they predict like if they are in line with the compliances of stock exchange. So what happens on Thanksgiving Day, the stock exchange close up early 1 hour, and this algorithms did not have any idea like if they have to take care of that timing thing into their consideration, and they try to flag all the 90% of a broker as defaulter, like they are doing a wrong practice. And once the data goes to the business analyst, this creates a confidence problem on the AI algorithms. So that is when you are communicating based on your AI product to the business user, then also the second part is how to gain their confidence. They believe in your what you have developed. Thank you. Thank you. I think. Thank you very much. I appreciate your being here. And if you still, I will be here all evening. So if you have wanted to discuss, we can discuss it later.